Hello everyone, welcome to watch this video. In this video, I will share with you the operation process of the handheld mode of Omnia Salium R8 Plus. Let's get started. Now I will introduce the installation process of our device in handheld mode. The first step is to open the equipment box. Then take out our handheld module and remove the protective cover. Install the pure plate. There is a screw at the bottom of the pure plate. Tighten the screw. Next, install the host module and battery. Okay, the battery is installed. Here is our shoulder strap. Each buckle on the shoulder strap has a lock. Remove the two buckles first. Then install them on the buckles of our host respectively. Then install the shoulder strap. Alright, the last step is to install the power cord. The long Type-C power cord is the one used for handheld mode. The L-shaped side is installed on the LiDAR module. The I side is installed on the host. This is the entire installation process of our device. After the installation of our device is completed, we need to turn on the power button of the device. There are 3 power buttons on our device. First, turn on the sensor. Then turn on the master after 5 seconds. Then, after 15 seconds, turn on the camera. Here, this is our entire boot up process. In fact, the startup sequence is the same for both handheld and backpacked modes. After all, power buttons are turned on normally. We need to connect the handheld device mobile phone to the device. They are connected through Wi-Fi. Now I will demonstrate to you how to connect. First, we swipe down from the upper right corner of the handheld device. Find the Wi-Fi switch to turn it on. Then long press it. Find the Wi-Fi of our device. The first one is our device's Wi-Fi. This is the serial number of our device, and also the name of our device's Wi-Fi. Then the password of this Wi-Fi is 128. Because my mobile phone has been connected to the device before, so I don't need to connect again. Now it shows that the connection is successful. Then we enter the browser and enter the URL of Omnia's LAM capture. The URL is 192.168.95.110.8888. Then we can get into Capture Operation Interface. First, we select System and find Config. In this configuration option, we need to turn the GNSS option to off. It is currently turned off. If it's a blue button, it means it has been turned on. We turn it off. Click OK. Now the GNSS option has been turned off. Then click Init. This process will take a few seconds. The initialization process is to check whether each module is operating normally. OK, now it prompts that initialization is successful. We click OK, then we enter the Project tab. Before starting the project, we can turn on the real-time display switch. Then during the operation, we can see the real-time display interface. Here is the Grab GCP option. We need to put the device on the control point. Align the point hole on the peer plate with the control point. Then click Grab GCP. A control point will be entered into the system. This is our entire process of connecting the handheld device, mobile phone, with our device. After the device is installed completely and our capture interface has been connected to the device, then we are ready to start scanning. But before scanning, there is one thing I need to emphasize. Our device must be placed on the ground statically at the beginning, and if we use control points, our device must start from the control point, just like now. Here is the position of our control point. So when we start scanning, our device should be placed on the control point to start. And the point hole on the peer plate must be aligned with the control point. Then, in the project name, we name the project Test1. Wait until our equipment is stable. Click Start. Our device needs a 15-second initialization time. After 15 seconds, the LiDAR head of the device will start rotating. Then we can start the work. OK, now our LiDAR head is rotating. Then click OK. Click Grab GCP. Click OK. Now, our first control point has been successfully obtained, and we can start the work. Follow my camera to see our entire operation process. This is our second control point. Click Grab GCP and click OK. Now our device is placed on the last control point, the position where our project ends. The scanning process must end at the control point so that the accuracy can be guaranteed. Then click Stop. OK, now our device has a self-check process. Our data check is done successfully. Click OK, and the entire project scan is over. After the scan is completed, we need to copy the data. First, open the USB shield, and then insert our USB drive. Now select data on the capture interface. Click Refresh at the top. Then select the project we want to copy. Click Refresh at the bottom. Click Copy. At the bottom, there is our copy progress bar. We'll start by copying the LiDAR's raw data, then 2 camera files. When the second camera file is copied, our entire project is copied. OK. Now it prompts that the copy is completed. Click OK. Click Eject. Click OK. This is our entire data copying process. Now, I will demonstrate how to get scanning project solution using our software mapper. After opening the mapper, click Create. Find Open, and open the path where our project is stored. Here, I need to emphasize that the file storage path can only contain English letters and numbers. Then we find Index and open it. Now the window shows the information of our project, including the path where our project is stored, the scanning time, the project name, and our workspace. This is where our output is stored. We can also change our endpoint. For example, I choose 50%. In this case, I will only process the first 50% of data, and the latter 50% will not be output. If we don't need the color point, cloud, or panoramic images, we can uncheck it. In this way, we only output the intensity value points. In most cases, we keep the default. Click Create and click Settings, because this project was collected in handheld mode. So we skip the GNSS setting and go directly to GCP setting. Select GCP setting. Click Reset. Now the interface shows the control points we obtained. Our tags start from 0, so there are 6 control points in this project. Then we click Import. Import the real coordinates of each control point, and before importing the coordinates, I need to show you the format of our control points. This is a CSV file. This CSV file is the format of the control points we import. Open the CSV file. We can see that there are 3 columns in the entire table. Some customers have encountered a problem before. Their control point file couldn't be imported into the mapper. After checking, we found that they put the data of 3 columns into the same column. For example, the data of columns B and C are placed in column A, which makes it impossible to import into the mapper. Here, I need to emphasize that some customers also feedbacked that with correct CSV formatting, the file still can't be imported into the mapper. At this time, you can try to select Save As to create another CSV file and import it again. Another thing is that the order of our control point coordinates must be consistent with the order when we collected. For example, the first line must correspond to the first control point in the project, which is our label 0. Our label 1 must correspond to the second row. This order must not be wrong. Okay, let's start importing. Click Import and find the GCP file. And click Open. Now, our coordinate file has been successfully imported. You can see that the east, north, and height have been displayed. The order of our 3 columns in CSV file is east, north, and height. This must not be wrong. Column A corresponds to east. Column B corresponds to north. Column C represents the height. This order must not be wrong. After importing the coordinates, we come to the output settings to select the output result we want. For points file type, we can choose LAS, E57. We usually choose LAS because LAS format takes up the least space. Then for output mode, we can choose 1 cm, 5 mm, and 2 mm. We usually keep the default and then check the remove moving objects. If we want to output a clean and tidy point cloud, we must check the remove moving objects. It can remove a lot of noise, including moving objects. After all the parameters are set, click OK. Then click Process. We can open the log file to watch our process progress. After Data Process, open the original folder. After opening the original folder, there is an extra folder named Process. This is the folder where we place our output. Open Output. This is all our process results, including camera accuracy evaluation, panoramic image trajectory, scan trajectory, and point cloud file. LAS file is our point cloud result file. And finally, there is our trajectory file. This is the output content of all our results.